So here is another worksheet on angle of contact. The first question is, what is shape of meniscus if angle of contact is acute? So it has got a concave shape as shown over here. Then if it is obtuse, then it has a convex shape as given over here. You see, this is the angle of contact, like here and like here also. So this is how we can simplify these concepts. Then it's a plane surface for 90-degree angle. It will be like plane, as you can see over here. So angle of contact between the contact surfaces is 90. Then if theta is less than 90-degree, liquid is called, it's a wetting liquid. So wetting in the sense that the surfaces will get certain fraction of water molecules or the liquid molecules stick to it. However, if theta is greater than 90-degree, the liquid is called non-wetting liquid, and there is no sticks left of the liquid, just like in case of mercury with pure silver. However, in case of theta is 90, liquid is called as the glazing liquid. So it's like that. And then is on what factors angle of contact depends. So angle of contact first of all depends on the nature of liquid solid interface, the temperature, and obviously the impurities. Then we have the Ascent formula or the Durin's law. So if you put a container, it is closed over here. So because of the force of surface tension, liquid move up, and the height then is given by 2t cos theta by 2 dgr. This is the Durin's formula. Now if we observe from here, so h1 upon h2 is r2 by r1. It is just make it open from over here, because it will be cancelled from up and down. So it's an open one over here. I'm sorry for that thing. So take it as open surface. Now here we have h1 by h2, that is r2 by r1. Inverse relation is there. Then we have a question like two capillary tubes have radii r1 r2 and liquids rises in them to heights h1 h2. So h1 is 2t cos theta by dgr1, h2 will be 2t cos theta by dgr2, h1 by h2 will be r2 by r1. Mass of the liquid is directly proportional to the radius. So m1 by m2 is r1 by r2. Weight is proportional to the mass, so that will again be r1 by r2. You see, this mass thing can be derived like mass is density into volume, and volume here will be pi r square h. So we can write it as d pi r into rh, and according to Durin's formula that rh term will be constant. So we can write it like h is 2t cos theta by dgr. So this r will get cancelled out, and we have the proportionality that mass is proportional to r. So based on this, we have m1 by m2 is r1 by r2. Weight will be proportional to the mass, g will get cancelled out, so that will be r1 by r2. Again, volume will be proportional to the mass, so that will again be r1 by r2. Then area is proportional to pi r square, so that will be r1 upon r2 whole square. Then is the case of a variable system in which acceleration is acting vertically. So we replace g by g factor. So in this case, it will be replaced by g plus g by 2. So after solving, with the expression will changes to h is 40 cos theta by 3 dgr. Whereas if it is moving downward, then replace g by g minus 2. And we have 40 cos theta by dgr. However, in case of constant velocity moving upward, we have acceleration as 0. So h will be 2t cos theta by dgr. If it is moved downward with constant velocity, then also acceleration will be 0. So h will be 2t cos theta by dgr. But in case of a stationary liquid also, h will be 2t cos theta by dgr. In case of any doubt, you can ask in the comment section. Thank you and have a nice day.